Hey my lovely warriors, hello my NEET and JEE aspirants for 2023. Welcome to the Gauss Law lecture and electrostatics problem solving session with me. I hope I'm audible as well as visible. Welcome aboard, and today's session is all about solving problems on the first chapter of your 12th standard, and that is electrostatics Gauss law. So many things are there. That's what we are going to do today in this session. It's going to be slightly more than 1.5 hours or around that time, and all of this is going to be done by me, your physics master teacher at Vedantu, your captain, your navigator, your friend, your guide. Hello Q being modified, hello, good evening. And if you are here, make sure that you put up your hello, hi, and make new friends in the chat box, because this is very important that you guys know each other, and also I get to know you, and make sure that you keep answering in the chat box so that I know how much you are able to solve. So make sure that your voice is heard in the chat box. And if you want to know more about me, you can definitely check me out on my Instagram as well. And before we begin, make sure you smash the like button and you are a part of the channel by becoming a member by hitting the subscribe. Your like and your support, your love is very important to me for conducting more such sessions, so that you guys get trained adequately well before your NEET or JEE 2023 examination. Good evening Ganesh, Anushka, Aishu, official Karthik. Aishu, I think I remember your name quite some time back. Hello Git, hello Suji, new to my channel, welcome, welcome. Thank you Prasad so much. Hi Textbook Terry Bunny, nice to see you guys. So get set go. Are you guys ready? Hi Damodaran Thomas, welcome, 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 all the lovely warriors. So today's session is all about problems, and everybody enjoys solving problems, and this will also tell you which type of questions you are not able to solve. And if you see that, okay, there are these questions which I'm not able to solve, I don't know the theory, let me tell you, I have a beautiful playlist of all the physics chapters of all 11th and 12th grade. Make sure you watch them after the session. Okay, stay tuned and make sure your participation is full on. Okay, full on. I want your answers full on. And here comes the first question on your screen. One metallic sphere is given a positive charge. Another sphere is given exactly the same charge, okay, about the same charge but a negative value. Then which of the following is true? Do I teach for KCET also? I will be conducting classes for local examinations maybe later on, my dear, but as of now, no plans of that. All right, so just hold on, let me just get your screen up over here. Yes, okay, great. Okay. Hello Tasuduk Teribani. Okay, you are from Tamil Nadu. Many people are from Tamil Nadu. Hi Sunandita, hi Amrut, hi student, hi Sanya, hi Rishi, hello Grande, welcome. So option A, some of you are saying option A. Well, I don't think so, my dear warriors, because think about it. Okay, let me get the pen. If both the spheres are given same amount, but one is positive, one is negative, when I say A has positive charge, and when I say the sphere B has a negative charge, that means this has extra electrons, whereas the one which has positive charge has less number of electrons. So mass of B will increase. So I think here the word decreases. This is wrong. This is correct. This is correct. This is wrong. This is wrong. Okay. I hope this is fine. Let's move on to the next question. But before that, make sure you're a part of the Telegram channel. That's where you're going to get all the important updates and notifications, including the PDF. Here comes the next question up on your screen. There is a charge Q, okay? It is lying exactly at the midpoint of the line joining the two similar charges, Q. The system will be completely in equilibrium if the value of small q is how much? Lots of questions, Roji thoughts, lots of questions we are going to solve today. So a charge Q is lying exactly at the midpoint. So let's say this is charge Q and it is lying at the midpoint of two similar charges. Let's say there is one charge over here and there is another charge over here. So the question is, what will be the value of small q if it is in equilibrium? Now one thing is for sure, that the similar charges, that is this one and this one, will repel each other. So there will be some kind of repulsion. Let's say I call it F1 between these two charges. But if this charge is somehow negative, then the force on this charge will be basically 0 if this force F1 is somehow balanced by this charge's force. If I make this charge as negative, then this force can be balanced by the attractive force of that small q. So I can give rise to a attractive force, let's say F2, on each one of them, so that the forces themselves balance each other and all the charges then stay in equilibrium. Everybody agrees with this? Rashmi, my wishes are always with all the students who are going to write the exam tomorrow. Stay cool and follow the advice that I have given in the previous class. So, what do? What is F1 and what is F2? F1 will be nothing but the force between these two charges, so it will be K into Q divided by the total distance. I can take it as 2D whole square. Whereas if I talk about F2 force, that will be K into Q into small q divided by the distance. Let's say I take it as D square. Q gets cancelled, like you can see very clearly over here. You will have one of the q remaining. D square will get cancelled. 2 square will become 4, and here I will get small q. So q magnitude wise, this is completely magnitude wise, is nothing but capital Q by 4. But sign wise, because it is attractive, that means it must be definitely negative in nature. So hence the answer should be basically minus Q by 4. So magnitude wise it is Q by 4, but sign wise it is minus Q by 4. I hope this is clear. Arsena, the possibility of exception of eligibility criteria in 2023, I doubt that will happen because of the pandemic years that was waived off. 90% chances that 75% eligibility criteria will be there, but maybe not for droppers. Maybe for droppers they might not consider that. Alright, moving on to the next question, my warriors, coming up on your screen, and obviously your favorite Pandu and Champa. Pandu is positively charged. He shakes hands with Champa, who is neutral. Then Champa comes close to Baban, oh my god, and who is also neutral. Assuming everybody has conductors, then Champa and Baban will attract, repel. Nothing will happen, can't decide, too confused. What do you guys say about it? Come on, my warriors. Think about it. 11th got wasted. How do I study both 11th and 12th now for competitive exam? You are in 12th now. If you are in 12th now, I would suggest 80% to 85% of the time with the current syllabus. I have made a strategy video for both JEE NEET students, competitive exam students, on how you can complete 11th and 12th topics together, which topics you should do together so that it will help in each other and you can complete the targets by December. So please search for that strategy JEE 2023 NEET 2023 exam, and you will find that block strategy which I have given for all the students. Follow all the tips for covering the backlogs over there. Alright, for tomorrow's exam, I made a video yesterday, Rashmi, just please make sure you watch it, and all my best wishes for all the JEE advanced students who are going to write the exam tomorrow. See, if Pandu is positively charged, Champa is basically neutral, and then we come to Baban. Baban is also neutral. Now if Pandu is positively charged and shakes hands with Champa, then what will happen? If there is some positive charge over here, some of the positive charge out of this will go to Champa. Some of the positive charge will definitely transfer to Champa. Now what happens is, Champa comes close to Baban, who is also neutral. Champa comes close to Baban, who is also neutral, then Champa and Baban will. So see guys, if Champa is positively charged, Baban is basically neutral, you might think positive and neutral charge will not attract each other. But that is not true. That is not true, because what happens is, because all of them are conductors, and in conductors charges can move freely, you will see some induced charges out here. So this positive charge will pull the electrons here, and there will be some equal amount of positive charge on this side. These are basically induced charges. What are these? These are induced charges. Now because of these induced charges, this positive will attract the negative charge and it will repel the positive charge. But since the negative charge is closer, since the negative charges are closer, they will definitely be stronger. They will be stronger. Here this is far away, hence it will be weaker, and hence you will see the net force on this conductor will be attractive in nature. So they will attract each other not because of law, because of the induced charge separated in that conductor, and the negative charge being closer, the force of attraction will be higher, like you can see in option A. There you go. Awesome. JEE 2023, I don't think the mains attempt should be in Jan because it's too late for that announcement right now. It's already nearing September. If they had to make the announcement, it should have been done by now. So chances of Jan attempt for JEE 2023 are very, very little. I feel it will be in March only, or maybe in April. Moving on to the next question. There is a charge block. It is projected on a rough horizontal surface with speed v0. The value of the coefficient of friction if kinetic energy remains constant is. Interesting question. Read the question. Yes, Gaurav, that will help you for all the competitive exams. Read the question carefully. It is clearly mentioned that the kinetic energy of the block remains constant. If kinetic energy remains constant, that means v square will remain constant. That means the acceleration should be how much, guys? If speed square remains constant, velocity square remains constant, because kinetic energy is constant, think the speed is not changing. That means the acceleration should be nothing but 0. If it is not accelerating, how is it possible? Because there is friction. The frictional force then must be balanced by some other force in this direction. So that will come because of the electric field, and the force will be nothing but Q into E. So that is the reason why you will see that the acceleration is 0 and the speed is constant. So you will just say, because acceleration is 0, net force will be 0. That means the charge into the field will be nothing but the kinetic friction. That means this will be nothing but mu into m into g. Kinetic friction is mu n. Normal force will be equal to the weight. So the question is, what is the value of the coefficient of friction? So hence the value of mu will be q times of e. mg, I will bring it downstairs. So qe divided by mg should be the answer. Just check this out. Yep, option A it is. There you go. No, it's not option C, it is option A. Awesome, guys. All right. No, sir, I meant special third attempt for JEE Advanced like this year. Not sure which question you are referring to, Arcane. Yep. All right. Moving on to the next question coming up on your screen. So this question was completely based on free body diagram, understanding the Newton's laws, that acceleration is not there, balancing the forces, and the force because of field is nothing but QE. Here comes the next question. 2 point charges are there, 20 and 80. They are 10 centimeters apart. Where do you think the field will be 0 on the line joining them? This is also a very common type of question. Let's try to solve this. Let's draw the charges first, 20 and 80 microcoulomb. So we have 20 microcoulomb and we have a separation of 10 centimeters, and then we have over here 80 microcoulomb, and somewhere in between the field cancels because 20 will give rise to an outward field, 80 will also give rise to an outward field. Somewhere they will cancel, maybe over here. You can assume the distance. The question is, find the distance from the 20 microcoulomb charge. So let me assume this distance as x. Naturally, this distance will be 20 minus x. So I can say at that point P, at that particular point P, the electric field due to 20, which will be this way, will be balanced by electric field due to 80 microcoulomb, which will be this way. That's it. What's the formula of electric field? It is K into the charge, which is 20 microcoulomb, divided by the distance square, so x square, is equal to, on the other side, it is nothing but K into nothing but 80 microcoulomb, and here we have oh sorry guys, I mistakenly put this as 20 minus x. It's not 20 minus x, it is 10 minus x. So sorry, 10 minus x. Okay, so I should put over here 10 minus x whole square. Now k micro gets cancelled, 20 and you have 80, so it will become 4. So 1 by x square will be nothing but 4 by 10 minus x whole square. Take roots on both sides, so it will become 1 by x is equal to 2 divided by 10 minus x. Cross multiply, so 10 minus x will be nothing but 2x. Naturally, if you take x on the other side, 10 will be equal to 3 times of x. So x will be 10 divided by 3. 10 divided by 3 is the answer, which I think should be nothing but option option, it is, 3.33 centimeters. It should be 3.33 centimeters. Here the option given is wrong. This should be 3.33 centimeters. That's it. I hope it is clear. Sir, get glowing, we need your magic. Yes, Harupriya, if you keep attending my sessions, definitely you will get that magic if you keep watching my sessions. Yep, that's what is going to happen. All right, shall we move ahead to the next one, guys? All right, moving on. Yes, so let's go to the next question coming up on your screen. Q, 2Q, 3Q, 4Q charges are placed at the four corners of this square. The field at the center of the square has a direction along. Interesting question. There are charges kept at that particular point. Where do you think is the direction of the electric field? Now, each charge, let's say I consider this Q charge. Because of this Q charge, at this point, the electric field will be this way. Correct? The electric field will be this way. Because of this, let's say 3Q charge, the electric field will be this way. But since the charge is thrice, so if this is E, this will be 3E field. Why? Because field is directly proportional to the charge. If charge becomes 3 times, the field will also become 3 times. I hope this is clear. Next important thing. Here 4Q charge is there. So at this point, the field will become 4 times of E because of this charge. Because of this charge, it will be this way and it will be 2 times of E. Let's solve this step by step. Forget everything else. Just look at these vectors and their directions. Now if you look at 3E and E, 3E field and E field, you can see E field cancels 3E field partially and I will be left with a 2 times of electric field in this particular direction. This 2E and that 4E will also partially cancel. So 4E minus 2E will again give you 2E in this direction. Right? So I have got rid of certain vectors by adding them or combining their effects. Now one last job before we move ahead, combine these two also. The resultant of these two undoubtedly is going to come like this. So this will be the net electric field. So it is along from D to A or C to B. So let's see, where is it? D to A or C to B? Yes, I think C to B is there right over here and option number B. There you go, option C to B. I hope this is clear. So what is the possibility to get exceptional third attempt for JEE Advanced in 2023 like it happened this year? I doubt, Arkin. I doubt. There are very little chances. I don't think so they will do it. If it happens, good. If it doesn't happen, I really doubt. Yeah, I mean, that's what we would expect. A metallic solid sphere is placed in a uniform electric field. The lines of force follow the paths. Which one? The reason why I'm saying that, Arkin, because till last year, everything was still closed. People were crazy. People were, in their homes and all of that. So maybe they gave that exception. This year, everything has opened up. So I don't think they will consider that. They won't give that leniency. So this is straightforward because this is a, metallic solid sphere. The condition that you should check is, number one, the field line should always be perpendicular and electric field inside the conductor should be 0. So no line should cut through it. Here's this line 1 is not cutting through the conductor, but the problem is it is making an angle which is not 90 degrees. If you see line number 4, it does not go through the conductor. Number 2, you can see it is also making an angle of 90 degrees. So hence, you will notice that the correct answer should be nothing but D, which is the line number 4. Always the electric field line is perpendicular to the surface. Perpendicular to the surface of a conductor. This is a very, very important rule which you should know. Yep, it is D. Yes, it is D. Yes, I am teaching, Prasad, the dropper classes, the AI live batch. I am teaching the AI live batch. But in the live batches, you have other teachers who are equally good. Yep, you can join any of the batches. Definitely. Gaurav, my native is basically Pune. I'm from Pune, Maharashtra. But right now, I'm happily settled in Nammauru, Bangalore. Okay. Yeah, no problem cubing. That's the whole purpose of conducting these problem sessions. In fact, I'm going to do a lot of things for you guys. You know, the advantage that I feel, and I feel very happy about it this year, is because since we have already covered the theory part and the sessions last year in the Pathfinder series, there is no point doing that again. I can build up your concepts over that by problems, good questions, nice hidden concepts, or some nice pointers which probably might have been missed out last year. So this is what I want to do this year, guys, with you. So I leave it up to you to watch those classes, or you can even join the Vedantu classes and you can cover it up. But this will be a value addition to whatever we have done in the last 1-2 years in Pathfinder and Nurture series. Let's move on. The electric field at a distance 3r/2 from the center of a charged conducting spherical shell of radius r is E. What do you think is the field at a distance r/2 from the center of the sphere? Okay, Chikbalapur. Oh my God, that's quite close. And yeah, you are very, very close to where I'm staying right now. Okay, somebody is saying option E/2, which is C. If you think about it carefully, you will realize that this is a basically conducting spherical shell. So remember, the charges will be only on the surface. Charges are obviously only on the surface, and the question says that the electric field at a distance of 3r/2. So this is nothing but 3r/2. Here the electric field at that point, yes, the electric field at that point is nothing but E. Here the electric field is basically E. The question is, what do you think is the electric field at a distance of basically r/2? What is the electric field? The answer for this is directly 0. All this data is irrelevant, because always inside a conductor the electric field is always going to be 0. No matter what is the shape, no matter how much is the charge, no matter what is the size, always field lies outside, just like explained before. Hence the answer should be option A, which is 0. There you go. Okay, so tricky questions. Moving on to the next one. Okay, very good, Kailash. Awesome. No problems cubing. It happens. Very good, Rishi. Awesome, awesome, awesome. Here we come to the next question. A surface is kept in ZX plane in electric field this much. How much electric flux do you think is coming through this surface? Let's try to understand. Let's try to understand how to solve this question. It's kept in the ZX plane, and the question, since it says it is in ZX plane, so if this is X, this is Y, and this is Z axis, so our surface is basically here. This is our surface. This has a surface of how many units? 10 units. So whenever I talk about flux, I should always take the field, into area, okay, into cos theta. That is one way of looking at it. Other way of looking at it is field which is piercing, the field which is piercing multiplied by the area. That's all. Don't worry about any other component, only that component which pierces through the area. If the area is flat like this, obviously the X component won't pierce, obviously the Z component won't pierce. It is only the Y component which is basically piercing it. So the Y component over here is nothing but 4, and the area is nothing but 10. Hence it should be nothing but 40 units. So 40 units is option A, and that is the correcto answer. Very good cubing method. I'm pretty sure you are now very happy about this. Yes, Rishi, it is option A. Very good, Kailash Bhaskar. Option 1, very good, Prasad Pachila. Awesome, awesome. So that is how you get it. Moving on to the next question coming up on your screen. 4 point charges, each of charge q, is placed on the circumference of a circle of diameter 2d in such a way that they form a square. The potential at the center is. So let's try this out. So first of all, let me draw a circle, beautiful circle, and 4 point charges placed on the circumference of diameter 2d such that they form a square. So let us also make a beautiful square over here, although it doesn't look like a square. And the diameter is also given. Now here you have a charge, here you have a charge, here you have a charge, and here also you have a charge. The question is, what is the potential at the center? So at the center, the potential will come because of this, because of this, because of this, and because of this. And the potential at the center is sum of the potentials due to basically each charge. And it is a scalar quantity. It's not like, oh, these two potentials cancel, nothing like that. It is not a vector, it's a scalar. So all the distances are equal. So it will be nothing but 4 times the potential due to any one charge. Any one charge. So it will be 4 times of. Now the diameter is 2d. So this will be d, this will be also d, this is also d, this is also d. So the distance of the center from any one of the charge is basically d. So it will be k times of q divided by basically d. So k q by d, but it will be 4 times of that. So hence option B should be the correct answer. Okay. No, Vijayalakshmi, the classes are conducted till March, but if by chance also, even if they conduct in, let's say, December, worst case, it's just to explain you what Vedantu is, we will change and allocate the classes accordingly. So don't worry about your AI Live classes. We know very well, it's not like once it is scheduled, we are not going to change. We will adapt, and I'm guaranteeing you 99.9% guys, JEE mains will not happen in January attempt. They would try to, but it will not happen because it's too late to conduct it in Jan. I mean, look at it, the counseling schedule only is ending. Counseling schedule is only ending in October. Do you think within next 2-3 months they will be in a position to conduct another exam? No. I think it will happen March end or April. Okay? Thank you. Thank you guys. Alright. Moving on to the next one. Coming up on your screen. Where do I live in Bangalore? I live in North Bangalore. Close to Hebbal. Okay. On moving a charge of 20 coulomb by 2 centimeters, 2 joules of work is done. Then the potential difference between the points is how much? Interesting question. Try to think how are we going to solve this. On moving a charge of 20 coulomb by 2 centimeters, 2 joule of work is done. What is the potential difference? The way I can define potential difference is the work done by the external force per unit charge in moving it from one point to the other. So if I move a charge from one point to the other, the amount of work that I need to do per unit charge is what is called as your potential difference. Let's see how to do this. So on moving a charge of 20 coulombs by 2 centimeters, 2 joules of work is done. So 2 joules comes over here. The charge is nothing but 20 coulomb. So this is just 1/10, which is nothing but 0.1. Obviously the answer is going to be in volts because it is voltage difference. You will be like, sir, what is the use of 2 centimeters? There is no use of it. It's just chumma given. Nothing, no use, guys. There is no use of this, 2 centimeters. It's just given to confuse students. Students will be like, oh, I didn't use it. Maybe I've gone wrong. To give additional stress. So these kind of things you should be prepared for in the exam. At home, you might not take so much of stress. But in the exam, many students take that. Moving on to the next question. The diagram below shows over here. Okay, the diagram below shows over here regions of equipotential lines. You can see 20 volts, 30 volts, 40 volts, so many things. You take a charge from A to B. You can see charge is taken from A to B in every situation. The question is, where do you think maximum work will be done? Where do you think maximum work will be done? Yep. Don't worry, cubing modified, you are not alone. If JEE exam comes in January, 99.9% of the students will be very, very unhappy. Maybe very few students who are like kirik parties, they will be like, ha sir, it is fine sir, no problem. But don't worry, there will be very few students who will be very happy about it. I am with you, even I will be unhappy about it. Okay, so let's try to solve this question. Work done to move a charge in all these cases. So the work done is always the charge, multiplied by the potential difference. Here to here, it is 10 to 40. It is 10 to 40, 10 to 40, 10 to 40. So the charge that you are moving is same. The potential difference is always 40 minus 10. And remember, this is always independent. It is always independent of the path taken. The work done in electrostatic field is always independent of the path taken. It only depends on the initial and the final charges. So there is no question of worrying about what is the shape, what is the path, how are you taking it. It should be same in all the 4 cases. Hence option B. Yes, cubing method, very good. Okay. Prasad Prachila, probably there will be a link in the description box for the Akrosh batch or the JEE 2023 repeaters batch. Just go ahead and click on the link and you will see that you will get variety of options. Choose the AI live batch. That's where you will find my teaching bacha. Okay, so don't worry, you will always find me over there. When one electron is moving towards the other electron, then the electric potential energy of the system decreases, increases, remains unchanged, becomes zero. Beautiful. Let's try to do this. Beautiful question. A lot of people get confused because it's an electron, especially with negative charges, people make some silly mistakes. So if I have one electron here, another electron here, and after some time I bring them closer. If I bring them closer, what do you think will happen? Will their potential energy increase or will it decrease? Now, you can go by the formula, but going by the formula, you might get confused or you can make some mistakes like this. I don't know. Like potential energy is K into minus E divided by R. So it will become K minus minus becomes plus divided by R. Now you can say because you are bringing it closer, so R will decrease. So denominator decreases, and once denominator decreases, the whole ratio will go up. Hence, the answer should be increases. Yep, that is the correct answer, I hope. Let's check it out, but there is another way of doing it. Yes, option B is the correct answer. But another way of doing the same question is, remember, whenever a system has high potential energy and whenever a system has low potential energy, always the system prefers the lower potential energy. Every system always wants to lower the energy, like you want to fall down, or a book kept on the top wants to fall down. So a system always goes from high to low. This is going to be a sad phase, this is going to be a happy phase. So you think in these two situations, who is happy, who is unhappy? When the electrons, they are repelling each other. Obviously when they are closer, they are definitely going to be sad, and here they will be much happier. So this is high potential energy, this is low potential energy. So that's how I know the potential energy increases. So this happiness and sadness is an easier way without formulas to check, not just for electrostatics, but for any chapter, any system, whether potential energy increases or goes down. That's all. So whenever stability increases, potential energy decreases. When instability increases, it becomes less stable, then you will see potential energy will also go up. Moving on to the next one coming up on your screen. Three charges Q, Q, Q placed on the vertices of an equilateral triangle side L. The net energy of the system is zero. The net energy of the system is zero. Do we need to study integration for NEET physics? Yes, definitely, Raj Moran. So there will be maybe one, max two questions, or maybe if you consider complete derivatives and integration together, maybe max to max 4 questions in the NEET exam. So if you want to crack that, you will have to do it. And not just that, most of the other things are dependent on derivatives and integration, so you need to do it. And every question matters, because every time you will be like, okay, I don't want to study derivatives and integration, so I'll leave that. Then you will feel the same thing about some other chapter. You have time now, so please put in your effort for studying each and everything. Okay, maybe in the end you can leave something, but not now, especially while studying. So the net energy of the system, whenever we have to find the net electrostatic energy of the system, find the energy between Q and Q, Q and Q, Q and Q, all the combinations, and add them up together. Like potential energy between capital Q and small q, plus potential energy between small q and small q, plus potential energy between capital Q and small q. Oh, this has come twice, so I can just write 2 times potential energy of capital Q small q plus potential energy of small q and small q. So this will be 2 into K divided by you have distance, which is L, and here you have QQ, here you have K into QQ divided by L, of course. So this should be 0. So you can see K cancels, L cancels, and one of the small q cancels. So this will become 2 times of capital Q plus small q is 0. So Q will be equal to minus 2Q. So the question is capital Q is equal to how much? So capital Q will be minus Q divided by 2. I hope you see that. Option C. Yes, it is option C. There you go. Option C is the correct answer. Yep. Coaching modules and NCRT are enough to score 150, 160 or around. But if you want to score in that 150 plus range, 140 plus range, 160 plus range, it is better to solve either H.C. Verma or D.C. Pandey like book to get that high score, or else you will be limited to only probably certain type of questions. You need to explore a little bit, okay, because 180 is not a joke, considering you have limited time, you have so many questions to solve, you have to think really fast. So you have to explore a little bit more than the usual. So I'm not saying any coaching, but in general, coaching modules cover a lot of things. Depends on which coaching you are comparing to. Vedantu also covers everything, but still I tell, for 180 marks, please solve something extra. Now, usually what happens in Vedantu, instead of solving H.C. Verma or something else, we end up giving sheets in the class or in the app itself. So apart from the coaching module, we give sheets, problem solving sheets during revision phase. That is called sprint material, rank booster material, so many things that we call internal names. So that helps the students, avoid the other books, and then they can just proceed with the sheets and the assignments and the coaching module, and then you can score well. So that is also enough. Yeah. So not necessarily exactly the coaching module, but the material given by the coaching is also sometimes more than enough. Okay. So moving on, the electric potential XYZ is given by something. What is the field at any point? Beautiful question, my warriors. Let's try to do this. So whenever we talk about field is always negative dV by dr. So negative gradient, negative derivative of the voltage with respect to the position. Now since it's an equation in X and Y, you need to differentiate it separately to find each component. So Ex will be minus dV by dx by treating Y, Z is not there. Here Y is basically a constant. Y is basically a constant. So when you take the derivative of this, it will be nothing but, check it out, derivative of this will be minus, with respect to X, 2x into Y, Y is a constant, minus 3x square plus 0. So Y comes outside, x square's derivative is 2x, x cube's derivative is 3x square. Now minus minus becomes plus, so it will become 2xy, minus minus again becomes plus, so 3x square. This becomes your x component. Similarly, my dear students, you can find the y component. This will be minus dv by dy. Here x is basically a constant. So if you do that derivative with respect to y, so x square is constant, so just x square comes. Y's derivative with respect to y is 1, minus 0, because x and 4 are constant. So this will just become minus x square. So my final result will be nothing but I will have 2xy plus 3x square I cap minus x square j cap. Let's see how many of you can get this. Oh, cubing method, electric field is V by D is only valid when field is constant. If it is not, then you have to use derivatives. So this is in general like instantaneous when things are varying. But if things are uniform, smooth, then you will use E is V by D. Yep, that's how you go about it. Will I finish all the 12 topics of JEE 2023 or in general 2023 SK? I have already done that in Pathfinder series. So I'm not going to teach the same thing. Here I'm going to do value addition to my previous series. So it will be like problem solving, mini concepts, good questions, tricky questions, PYQs. So that is what you can expect me to do, not the same theory again and again. That's no point. Can I still join my Vedantu class on English channel? Definitely, Haruklava, Chenukual, definitely. The teachers who are teaching in the AI Live Droppers batch this year, in the English batch, it's obviously me, and you will also have Shimon sir and Harsh Maheshwari sir. Yes, so these are the teachers who will be teaching in the AI Live Dropper batch. Okay, and in the 11th and 12th batches, anyways, I am teaching as usual. Great. So if a charged spherical conductor of radius 15 has potential V at a point 15 centimeter from the center, then the potential at a point 3 centimeter from the center is going to be how much? Let's try to do this question. So we have a spherical charged conductor. Remember, for a charged conductor, the charges are only on the surface and the radius is 15 centimeters. This is 15 centimeters. The potential at a point 15 centimeters is nothing but how much V. So the potential at this particular point is V. The question is, at a distance of 3 centimeters, what is the potential here? Well, let me tell you, very simply put, inside the electric field is 0. If electric field is 0, potential will be? If electric field is 0, what will happen, guys? Potential will not change. Potential will not change. Why will it change? Field is 0. There is no field. There is no need for potential to change. Field always goes from high to low potential. Field goes from high to low potential. So there is no potential difference. There is no potential change. Field will not flow. So potential is basically constant. So inside there is no field. So potential is not going to change. It's same. So if it is V here, obviously the value of the potential here will also be V. It will not change. Hence the correct answer is obviously option D. Great cubing. Awesome. V in V surface everywhere is going to be same. Hello Maheen. Welcome bacha. DC Pandey or Sengage, Charan Sai Gumtala. For physics, I would say DC Pandey. Okay, maybe for maths you might use Sengage, but for physics, please do not use Sengage. Prefer DC Pandey. Okay, not because DC Pandey sir comes and gives me commission or anything. No, nobody gives me anything. It's for your benefit. I have seen all the books and I know what works and what doesn't. Okay, so that's what it is. Moving on to the next one. A dielectric is placed in an electric field. Then what is the direction of the induced field? Is it same? Is it opposite to external field? Is the magnitude same as that of the direction? Crazy. So many questions are there. So many options are there, sorry. So figure out which option is correct. Good evening, Yasmita Chaudhary. Welcome. Hello, Maheen. Welcome, guys. Let's see how we can solve this question. If you place a dielectric, this is, let's say, a dielectric in some external field, then what happens is, if this is your external field, then there is an induced field. I will call it E induced, because of which the external field reduces. So the net field is the external field minus the induced field. So if external field is here, induced field will be slightly opposite, and whatever is remaining will be the net field. So now look at the options, guys. Look at the options. Check which one of them is correct. The direction of the net field, I think, is same as the direction of the external field. Net field and external field, yes, they are in the same direction. Magnitude of the induced field is same as that of the direction of the, how can the magnitude be same as the direction? No, the direction of the induced field is same as the, the direction of the induced field is same as the direction of the external field. No, induced field is opposite to the external field. It's always opposite, like you can see. Hence option C should be correct. Option C should be correct. Yes, the magnitude of the induced field is less. Yes, the magnitude of the induced field is always less than the magnitude of the external field. This is correct, not anything else. Option C is definitely the correct one, completely based on theory. Let me tell you, in the past few attempts, a lot of questions have been coming directly on theory and statement based questions, be it NEET or be it JEE. If you open up 2020, 2021, 2022 papers of NEET JEE, you will see many times so many statement based questions have been asked in these papers. Okay, I will call your name clearly. Let me read it properly. It's Ruhaipua Chenikwal. Oh my god, it's very difficult. Sorry, my dear. If you have some pet name, please let me know. It's a little bit difficult for me. Ruhaipua Chenyukal. Is that how you say it? Good evening, Isha Shalul. Hi, Kailash Bhaskar. Okay, yes, it is going to be opposite. Okay, let's try to solve this question. Charge of 2 coulomb is placed at the center of a cube. So if you draw a cube over here, and if you place a charge at the center, then whatever flux goes here will be same. will be same, right? So what's the flux through any side? There are 6 faces, top, bottom, left, right, front, back. So it will be nothing but 1/6 of the net flux through the cube, and using Gauss's law, the flux through a closed surface. So closed surface is nothing but the charge by epsilon naught. Now this charge is given to be how many coulombs? It is 2 coulombs. So 2 and 6 cancel. So 1/3 epsilon naught. That should be the answer. Let us have a look. Option A. Yes, it is. It is option A, guys. There you go. Yep, option A. Very good, Rishi. Yep, option A, Kailash. Awesome, SK. Hello, Konduru, Sai, Vivek. Sir, how much weightage does this chapter have? You can expect be it NEET or JEE, 2 questions from, or 1 or 2 questions, or sometimes it's dependent. They combine it with magnetism or modern physics or Newton's laws. So 1 to 2 questions you can expect. Yep. Moving on. Yes, messed up with the numerator and the denominator. All right, moving on to the next one. Can I crack JEE Mains 2023 starting today? SK, definitely, bacha. A lot of students have done that in the past, and you can also do it. But follow my schedule, which I have given just few days back. Just search on the channel itself. It's there. Block strategy by me. Just search block strategy Shreyas sir, JEE 2023, NEET 2023. You'll get it. Follow that schedule strictly. Even if you have missed few days, it's okay. Try to compress the time. Try to make up for whatever you have lost and do it. Okay, you still have good 6 to 8 months. Things can change. Here it comes. A hollow cylinder has a charge of q coulombs within it. If phi is the electric flux of in units of volt per meter, and it is associated only with the curved surface, then what is the flux through any circular face in this particular question? Hello, Nagina Sheikh. All right, moving on to this question. Let's see how do we do it. First of all, it's a closed surface, the cylinder. The net flux through the entire cylinder, according to the Gauss's law, will be the charge which is inside by epsilon naught. Great. The charge Q which is inside is nothing but Q, and this is epsilon naught. Now, what is going to happen is the flux is going to come from this side. It is also going to come from the curved surface, and it is also going to come from this side. Now, can you not see that this side and this side, magnitude wise, the flux is same? The flux is going out on the side A, and it is also coming out from the side C. So the flux is same. Okay, so I'll just spread it out right now. Flux through A plus flux through C plus flux through B is the total flux through the cylinder, and that is Q by epsilon naught. Now these two are basically same by symmetry. So I can say 2 times phi of A plus phi B. The flux through the curved surface, it is clearly mentioned, curved surface is phi, is Q by epsilon naught. So 2 times phi A is nothing but Q by epsilon naught minus phi. So phi A, the phi A will be half Q by epsilon naught minus phi. That is the answer. That is the answer. So is that option A? Yes, it is. Like you can see. Maheen, I am taking the AI live batches of all the 11th and 12th and dropper. And in the live batches, you will see other teachers who are equally good as me or even better. All right. So you can join any batch that you want. Very good, Ankesh. Very good. Awesome. Awesome. So correct answer is option A. Beautiful thing is that you should realize that both these surfaces will have same flux passing through them. Else, if you miss that, you will definitely be confused in this step or make some stupid mistake or ignore that too, and you might get option D. So be little careful over there. Here comes the next one. A ring-shaped conductor with the radius A carries some positive charge uniformly distributed as shown in the figure. The figure is missing, but you can visualize. Point P is at a distance x. Which of the following graph shows the correct variation of the field? All right, so let me just show you what I'm exactly talking about. This is basically your ring, and it is uniformly charged. And here is basically your x-axis, which goes on both the sides like this. This is your origin. This is your x-axis. This is your negative x-axis. The question is, how will the field look like? Well, if you are at the center, obviously the field from all the sides, from the top and bottom, from here and here, from here and here, from here and here, everywhere it will cancel. Everybody agrees? So at O, electric field at O should be 0. Electric field at O should be 0. Now you can clearly see over here the electric field is definitely not 0. So this is out of question. Okay, this is out of question. Next thing, if you go on this side, these positive charges will definitely repel. So the net field will be also positive. So when X is positive, electric field is also positive. If you go on the negative side, the electric field vectors will be somewhere here. So the electric field is also negative when X is negative. Here if you notice, when X is negative, here E is basically positive, and when X is positive, E is definitely negative. So this option gets ruled out. So there is only option C out there, which makes perfect sense. When X is positive, E is positive. When X is negative, E is also negative. It passes through the origin. All the characteristics are obtained. Awesome. I hope this is clear. Option C is the correct answer. Okay, so graphical based questions are also common in JEE and NEET exam. It's completely based out of your understanding on how you are going to think of that situation. Graphs is nothing but how you interpret a formula or a situation, and do you understand a trend, or do you understand some special points which are to be taken into consideration, like here whether it's positive, negative, 0 and such things. Moving on to the next one. Same problem. SK says, Maheen, SK, sir, if I concentrate on JEE, will it affect my school studies? No. If you keep half a day in a week or one day max to max, actually half day is more than enough, you can easily crack the school studies, and school studies can run parallel to JEE studies. That's what all the students do, and it's always better to concentrate on JEE so that you can automatically understand the school syllabus. Just the extra thing is writing the answers. So if you are a CBSE student or some board student, whatever back exercise PYQ is there and whatever school examples are given, just write it and practice it whenever you find time. That is more than sufficient to keep you in touch. Otherwise, once you understand things, you can easily crack with very good percentages. Even an average student can get more than 90% with just this much. Okay. Kailash, yep, you can copy this problem definitely. A thin semicircular ring of radius r, but you will get the PDF, okay? You'll get the PDF after the session. A thin semicircular ring of radius r has a positive charge as shown. What is the net field at the center? Okay, first things first, if all these charges are there at the center, this charge will give a field here, this charge will give a field here, okay? This charge will give a field here, this charge will give a field here, this charge will give a field here. The net field will be obviously like this. The resultant of all these fields, one is here, 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 here. Some fields will cancel, all the horizontal components will cancel. The only component which will add is the downward field. So it will be in the negative j cap direction. Now you can clearly see this is I cap, so this is ruled out. This is positive j cap, this is also ruled out. Tanish Rathore, I'm very good, bacha. I hope you are doing great. Welcome to the session. So now comes the magnitude. Well, there is a formula. There is a formula for rings or arcs subtending certain angle. Here the angle subtended is pi radian. That is nothing but 2 times of Coulomb's constant divided by r. Okay, and here you will have lambda. Here you have lambda, and here you have basically sine of phi by, or basically the angle by 2. So this is the usual formula. This is the linear charge density. So basically over here, you can see that, well, k value is nothing but 1 by 4 pi epsilon naught. Here you have also 1 by r. Lambda is charge per unit length. So the charge is nothing but q, and it is divided across pi r radius. So pi into r will come. Sine of this will be 90 degrees because pi by 2 is 90. So it will be nothing but just 1. So you can see from here, this 2 and this 4 will get cancelled. So I just have q by 2, and I have pi and pi square, and I have epsilon naught, and I have r and r, which is r square. So this is the magnitude. So 1 by 2 should be there. So I can see 2 over here. Naturally, this will go out because of this 4. So answer should be option C, and yes, it is option C. So this is the formula when you have an arc which is uniformly charged, and phi is basically the complete angle which is subtended. Lambda is the charge per unit length. Here this is the length. This is the length, or this is the length of the semicircle. Semicircle. That is why I have put that. Charge per unit length. Okay. So this is how you're going to do it. Moving on to the next one. Coming up on your screen. Two parallel infinite line charges with linear charge density plus lambda minus lambda separated by distance r. What do you think is the field exactly in between them? Okay. Rashmi, the first subject to attend, it's up to you. Please go with your strengths first, and once you have crossed the time limit, switch to other subject because you have to clear individual cutoffs. Keep that in mind. So do not exceed the time limit. Once you feel that you have done adequate questions, move on, and always go with the confident subject first. It could be chemistry also. Chemistry is usually relatively easy as compared to physics or maths. All right, so let's try to do this question. Two parallel charges, this is plus, this is minus, and plus lambda minus lambda at a distance of r. Question is, what is the field? What is the field midway? So this is basically r by 2. This is also basically r by 2, and we have to find the field exactly over here. Now please understand, because of this positive charge, the field will be this way. Because of this negative charge also, the field will be like this. In fact, the net field will not cancel. A lot of people think answer should be 0. No, it is not 0. It will add. So it will be field due to the positive plus the field due to the negative. It will be 2 times the field due to any wire, because both the charge densities are same, both the distances are also same. So it will be 2 times the field due to an infinitely long wire is nothing but 1 by 2 pi epsilon naught r. Here r is nothing but going to be r by 2, and here you will have lambda. This is what it is. So now what will happen is this 2 and this 2 will cancel. So I'm just left with 2 lambda divided by pi epsilon naught r. Pi epsilon naught r. So 2 lambda divided by pi epsilon naught r is option D, I suppose. Yes, option D is the correct one. Great. All the best, Rashmi. Take care and see you tomorrow. Hopefully you'll come up with a very smiling face and good results. Hi Mahesh S. Hi ma'am. This is not ma'am, this is Sir Mahesh. Probably screen resolution is not great. How can we revise completing backlogs? Ganesh, keep a schedule and do partial revision chapter wise. Make a 3 to 4 month plan of which chapters you are going to revise, and slowly revise those questions which you are not able to solve before. Start with easy ones, go with difficult or unsolved ones, and keep it till JEE mains level or NEET average level, and then you can push yourself during revision after your syllabus is over. Okay. Yeah. So a lot of students make that mistake. Many people substitute, instead of r by 2 they put r, and once you substitute r, you probably do not get this 2 over here. You will get some C or A option, something like that. So you need to be careful. Okay. So 0 to hero series sufficient to crack JEE? No, Tanish, nothing is sufficient to crack JEE. You have to keep on trying. That's the reason why I'm conducting this session. So if it was enough, I would have probably done something else, or maybe, I don't know, I would have taught maybe 9th and 10th kids. The reason why we conduct so many sessions is because nothing is ever enough for JEE. So if you think of the word enough for JEE or NEET, and that's it. That's the first initial signs of losing marks. Okay. So let's try this question. 2 parallel thin metallic sheets have equal surface charge densities, opposite signs, the field between the sheets. Okay, so this is simple. This is positive, this is negative. Again, very similar, but these are sheets. So because of the positive, the field will be here. Negative also, the field will be here. So I can just say that the net field will be because of the field due to the positive plus the field due to the negative charge, and it is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Both will add, so it will be sigma by epsilon naught. Now sigma is given, epsilon you know, so sigma is given to be 26.4 into 10 to the power minus 12, and epsilon is nothing but 8.85 into 10 to the power minus 12. Okay, 20 to the power minus 12 cancels, 8 3s are 24, so close to 3, option C, C for captain. There you go. Okay, Kailash, at least per day you should solve 50 problems. Okay, but it depends on what exactly you are doing. If you are studying some new chapter, you might take time and you might solve maybe 30 problems or 20 problems. But once you are in that momentum, then probably you can push yourself to 70, 80 problems per day, not more than that. Okay, because if you do not have time, especially, why I'm saying not more, because what happens is people try to solve a lot of questions. Like I've seen many institutes do this. They make students solve 200 questions, 150 questions from morning till night. It's more like, you know, you are by-hearting those questions. You are not spending quality time with the question. So always spend time with the question to digest the concepts, understand what things are happening. So even if you solve 50, 60 questions, 40 questions, 70 questions, that is also a good number. Okay, you will learn a lot of stuff, but spend time in the question on what are the different ways of doing it, can you manipulate it, and so on and so forth. Moving on to the next one coming up on your screen. Which of the following graphs shows the variation of the field due to hollow spherical conductor of radius r as a function of distance from the center? Graphs, variation, field, hollow. Interesting. So if you have a hollow sphere, nothing is there inside, I know that the field inside will be 0. And outside it is inversely proportional to r square. So there is only one option like that. Do you see? Here the field is 0 and here it is inversely proportional to r square. Here no, it is proportional to r, increasing. Nowhere it is 0. There is only one option like that. Option A is the correct answer. Okay, so that's for a hollow sphere. One more question probably on graphs. I think I had put it. Yes, there you go. Let's try to see how many of you can do this. A uniformly charged non-conducting sphere and radius r, the field as a distance r will be what? It's a non-conducting sphere. That means the charges are basically there everywhere, even inside. It's a non-conducting uniformly charged sphere. So in such cases, what happens is when you're inside, it is directly proportional to r, and when you're outside, it is inversely proportional to r square. Inside, it's proportional to r, so proportional to r, and outside, inversely proportional to r square. So I can see this option, it is directly proportional to r. Here it is 1 by r square. So yes, it should be option C, I guess. Yep, it is. So this is how it works when it is uniformly charged non-conducting sphere. Moving on to the next question coming up on your screen. The variation of the potential with distance from the center of a positively charged metallic thin shell is which one? So it's the variation of potential, guys. Come on, figure this out. When we talk about potential, remember field is 0 inside. Here field is inversely proportional to r square. Because the field is 0, that means the potential here is basically constant. Here you will see that the potential is just inversely proportional to r. It just behaves like a point charge. Whenever you are outside, any sphere behaves like a point charge, but the problem always happens when you are inside. So I think it should be option B. You can see that because over here it is definitely constant and here it is proportional to 1 by r, of course. Option B. Very good cubing, very good. Ganamadadi T 2.0. Oh my god, why are so difficult names coming up today? All right, so godly tryouts. Please watch my yesterday's session. I have given 9 important pointers. Relax yourself now. There is no point studying because you are going to do extremely well. Please watch that session. It is 30 minutes. You can watch it in 2x speed also. That's okay. Very good, Prasad. No, Amit, it's not C. It is option B. Moving on to the next one coming up on your screen. All right. So let's see how many of you can do this. There is a point charge q which is kept at a distance of 2r from the center of an uncharged shell of radius r. The potential at the center of the shell due to induced charges is. So you have kept a charge q over here if you have kept a charge q over here, what will happen? This positive charge will pull some of the electrons here. If I see 4 electrons here, an equal amount of positive charge will be developed here, and these are basically your induced charges. And the question is, what is the potential at the center due to the induced charges? Now if you sit on the center, what will happen? This charge, 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 all are at the same distance r. So the potential at the center, will be the sum of potential due to all the induced charges. And since all the distances are same, it will be k divided by r. It will be just summation of all the charges which are basically induced. kq by r, kq by r, kq by r. R is same for everything. So basically what will happen is the sum of the charges will be 0, because how many ever negative charges are there, exactly that much positive charges are there. Hence the correct answer should be basically a big fat 0. Okay, so you should understand the numerator has got added up. So that's why you will see that since the total charge should be conserved, whatever negative charge is there, exactly same positive charge will be there. Okay, is that clear? Everybody with me on this? Moving on to the next one coming up on your screen. 4 charges are placed on the vertices of a square of side A as shown. The magnitude of the dipole moment of the arrangement is asked. Beautiful question. Let's see. What is the meaning of dipole? Equal and opposite charges. Okay, can I see some equal and opposite charges? Maybe not everywhere, but this minus q and plus q, look at this minus and this plus is one dipole. It's one dipole going like this. Okay, then out of 3q, one of the plus is gone, then 1 minus and 1 plus over here. So 1 plus and 1 minus, so that is another dipole maybe over here, and this minus and 1 remaining plus, so there is 1 minus and there is 1 plus here, so that is also one of the dipoles. Check it out. So these are the 3 dipoles. I hope you guys can see it. Everybody with me on this? Okay, what are the lengths of the dipole? This is side A, side A, side A, side A. So this is A, this is also A. Oh, but this is the diagonal, so it is going to be root 2 times of A. Okay, so what will be each of those dipole moments? This will be nothing but QA, charge into length. This will be also QA. This will be nothing but Q into root 2A. Root 2A, that's the dipole separation into the charge. I hope this is clear. Everybody with me on this? Amit is saying D. Yep. Amit, lot of students make that mistake. Okay. So there is one small catch. You will see now. Now observe this, guys. This QA and this QA together, I can combine it into one vector. Okay. This Q root 2A, I'll just write it as it is. So this is the next step. Maybe I can just write it over here. So this Q root 2A is as it is. I'm just copying it over here. But these two of them, I can add them vectorially. So QA plus QA, one is in X, one is in Y, will give me a vector in this direction. So it will be this way. It will be nothing but QA into root 2. Do you agree with this or not? Do you guys agree with this or not? Come on, think about it, my warriors. This QA and this QA together will give QA root 2. Now that I have got rid of 2 vectors and combined it into one single vector, I just need to bother about these 2 dipoles to be added. So think about it. When I add these 2, what will I get? When I add these 2, what will I get? I will just get, because their directions are same, so Q root 2A plus Q A root 2, which is one and the same thing. It will be 2 times of root 2 times QA. So that is the answer, which is not option D. I believe it is option A. Yes, it is. A lot of students make that mistake. Yes, very good, Amit. Finally got it. Very good, cubing modified. You are slowly getting it. No, Lokeshwar, it is not D. A lot of students, you know what they forget? They forget this distance is root 2A, and that is why you write option D, because you think, oh, QA, QA and QA, 3 vectors to be added. Standard problem which you have done in vectors. No, that is not true. All right, moving on to the next one. So these are the typical catches, and that's why you should attend the problem solving sessions. I'm going to conduct all these problem solving sessions, important questions, PYQs, hidden concepts, tricks, all these sessions in Ultra Legend series for 12th standard JEE NEET students, 2023 aspirants throughout the year. So make sure you have hit the subscribe, and if you're loving the session and you want to shower your love, you have smashed the like button. It means a lot, and thank you very much. Moving on to the next question coming up on your screen. Electric field at a very far away distance on the axis of the dipole is E naught. And what is the question? The question is, what is the field at a distance 2r on the perpendicular bisector? Good evening, Yasmina Bano. Welcome, welcome, all the lovely warriors. So, if you have a dipole, like this, and if you are on the axis and at a distance r, and the question is, at this distance, the field is basically E naught. Remember, the field's formula is 2kp divided by r cube. This is the formula on the axis. Now, the moment you go on the equatorial position, the electric field at a distance 2r on the perpendicular bisector, that's equator. Here, the field will come this way, and the field on the perpendicular bisector is given by just kq divided by this distance q. So 2r's whole cube. First thing I notice that this field is opposite to this field, because if you remember the electric field lines of a dipole, they go like this, right? This is how the electric field lines go. So the electric field lines are basically, on the axis they are this way. So on the equator they come back. So it should be opposite. That means option A is wrong, option C is also wrong. Both options are ruled out. Only those options which have negative sign should be considered. Only those options which have negative sign will be considered. Yes, very good. Yeah, very good. So now the only thing is with which magnitude is right. So if you see over here, I can just rearrange this, and I can see that E naught by 2 is basically kp by r cube, and over here I get I put q, guys, I'm so sorry, this was supposed to be p, not q. Yeah, here I get kp, 2 cube is 8, and r cube. So here I can write 1 by 8, kp by r cube. From there is nothing but E naught by 2. Hence, the final solution will be E naught by 16. This is magnitude wise, but direction wise it is exactly opposite. So hence, it should be nothing but option B with the minus sign, of course. Yep. Ishika, yes, Shimon sir, he had, I think, COVID, and he has recovered now. He will be recovering, and completely recovering very soon, and he will be coming back. So don't worry. Yes, he will be taking classes. All right. Moving on to the next one coming up on your screen. The figure shows the electric field due to dipole placed as shown. Which of the following is correct? Come on, guys. Think about it. Figure it out. The dipole will not experience force. It will experience force. What do you think will happen? The way it has been kept, this positive charge will experience a force this way. This negative charge will experience a force this way. Here the field is basically strong because the lines are close by. Here the field is weak. So obviously the force due to negative charge is more than the force due to positive charge. So the net force will be definitely towards the left side. But I don't think there is any torque because the forces are along the same line. They are co-linear forces. A co-linear force can never give any torque. So here the torque will be 0. But the moment one of the forces here, there is some separation. In this case, the torque is definitely not 0. There will be a torque that's called as a coupled torque. So you will see that the correct answer will be the dipole experiences a force towards the left side. Yep. Hello, Vishalani, welcome, Bachalo. Yes, definitely. Our prayers are with everyone. Yes, Ishika, don't worry. Everybody will be fine. All right. So moving on to the next question. Electric dipole of moment P is placed parallel to the electric field lines. Now the work done in deflecting it through 180 degrees is how much? Hello, St. Tyson. Nice names, huh? You guys figure out. I remember in my days to figure out the nice email ID, we used to struggle a lot. You know? So in those days, emails was new when I was just in school, and we used to all this. Your names just remind me of our email IDs. It used to be crazy, based on cricket stars, based on all these WWF players, and also actors and actresses, and so many crazy names people used to put. Whosoever is your favorite hero, heroine, will put our IDs based on our idols. And I can see a lot of you putting even more crazier names. I don't understand. Maybe you guys have some real crazy feelings, or maybe crazy dreams. Who knows? Yeah. Welcome, Semi Gaikwad, and I hope you continue. And this will not be the last time, and your last time will be next year or next to next year, depending on whether you are 11th or 12th students. Be regular on this channel, because a lot of problem solving sessions, questions, important notices keep on happening on this channel. A electric dipole of moment P is placed parallel to the lines of force. So if the dipole is placed like this, think about it, and it is rotated by 180 degrees. So right now it is at 0 degree, and now you make it exactly opposite. So here it is 180 degrees. Then what is the work done to deflect it? Now the work done is basically the change in the potential energy, which is final minus initial. Final minus initial. So whenever I do work, it changes the potential energy. So final potential energy will be minus PE cos 180 degrees. This is final. Remember, potential energy formula is minus P dot E. That minus is very important, or you'll make a mistake. And here also it will be minus PE cos of 0 degree. Now this will become minus P cos 180. Cos 180 is also minus 1, so it will become plus P. Now this minus as it is. Cos 0 is 1, so it will become minus PE. So it just becomes 2 times of P times of E. That's all. So 2PE is the option. Yep, not minus. If you make some stupid mistake, you will either get A, C, or D. So be very careful, and very happy Q being modified, you got the correct one. No, it's not C. It's not C. Yep. Great, great, great. Moving on to the next one. Oh, we have come to the end of the class. Oh, this is the homework question. You're going to put up the answers in the comment section. I want you to see, I want myself to see how many of you kids are going to put up the answers in the comment section. And even if it is wrong, it's perfectly okay. And I want you to compete against each other, help each other. The answer and the final solution will be uploaded in the Telegram channel. So make sure you're a part of it. If you're not a part of it, please download the Telegram app as well. It's very important because you get updates, notifications. A lot of things keep on happening on Telegram itself. Okay, so I hope you guys enjoyed the session, and I'm hoping that you have also smashed the like, and you're going to share about this channel, not just physically, but also when you meet your friends and batchmates. You should talk about your Enlite channel, and you should be very proud that yes, I'm a part of it. This is the channel for all the English speaking or English medium students across the country and even outside the country. So be a part of it, get your friends, your relatives, cousins along, and do not forget to subscribe, because that's how you get all the next videos coming up on your YouTube app as well. And also make sure that you leave a comment, whatever you feel like. Even if you were not able to solve the homework question, just say hello. I'm okay with that. Okay, thank you very much. Bye bye guys, take care, have a wonderful night, have your dinner, take care, and God bless you all. Keep studying, keep working. See you in the next class. Hasta la vista. This was Captain Shreyas.